Hello all. Let's start with our today's DSA journey with this amazing code.com. Use this link to get a 7-day free trial. Okay, so let's start with our today's DSA. And our today is min stack. A simple question. A very simple question. Design a stack that support push, pop, top, and retrieve the minimum element all in big O of one time. As we already know, and top. These three operations of stack are actually take big O of time, but we have to retrieve the minimum element of the stack. Okay, so how could we do this? So this is our question, min stack. So actually we are given a stack. Let's suppose okay, I am new with TL draw. So let's suppose we have a element 5. Okay, and another element is 6, another element is 3. Okay, so we know when we push a element into the stack or we pop a element into the stack or the top element of the stack, we can easily get it big O of one time using our inbuilt function. But how could we ensure the minimum frequency? Okay, what is the minimum of the stack of currently? Let's suppose we insert 5, then we insert 6, then we insert 3. What is the minimum of the stack now? It is 3, this 3. So we pop the element. What is the minimum of the stack now? This 5. So whenever in this condition we actually given to we actually asked to give the output of the minimum element 5. But how we can do this? Because not every time the minimum element should be in the top. Okay, so if we pop it, now the minimum element is 5. But if we push 2, the minimum element is 2. If we push 6, push 3, so every time the minimum element is this 2. So how could we ensure this? Okay, so first okay, let's pop out everything. And our approach is simple, very simple approach. It in big of one time. Okay, because our task is to perform everything in big of one time. So one is our stack st to store the value, or rather say it as main. And we have another stack to store the minimum value to store all the minimum value. Okay, so first we push 5 here. Okay, so what is the minimum currently here? The minimum is 5. Okay, now we push 6 here. What is the minimum? 5. So we push 5 here. So now we insert 2. What is now the minimum? Now the minimum is 2. So we push 2. Now we push 3 here. So what is the minimum? Also the 2 is still the minimum. So we get 2 here. So whenever in any cases, if any cases, we can easily we can easily pop element from this minimum stack or this stack means. So using this stack, we can easily get our value. So if we got to the this moment to give the minimum, this is nothing but this top element, which is 2. Okay, so if when we pop this, we also have to pop this. So when we are popping, we have to pop from both elements so that it matches with each and everything, because everything is mapped here. So when we actually remove this 2, we also remove this 2. So now the current minimum is 5 and the top element is 6. Okay, so this is our approach. We'll using we will use stack. Okay, so first use to stack and not means, let's suppose means. Okay, so the push element, when you have to push a value, suppose x, push into the main element, so main dot push, so push into the main stack. Also in the means, when you are actually pushing it, first check what is the mean. Okay, so every time let's suppose in this position, when you want to put 2 here, okay, so we have to check this value of 2 with this top value 5. So if this 2 is less than this 5, we will put this 2 here also, but if it is not less than 5, we will put this 5 also here. Okay, so similarly let's see here. So when we actually push this 6 here, so we check this 5 of this minimum is less than this 6. Yes, it is less than, so put 5 here. So when we put 2 here, we are checking this 2 is less than 5. Yes, it is less than 5, so we put 2 here. So this is how we mainly do it. And how we do it? We can easily do it using this mean. So the means of x and mean, that mean, the top of the main stack, okay, which store all the value. This is our actual push. So when we actually pop it, simple function pop it, so it pop from both. Okay, so pop from, so we pop from both array, so that we can easily map. So when we pop this two, this 6 maps to this 5. So now if anyone wants this means, we easily get this 5. Okay, now push pop and top. Okay, so top, top is nothing but, what is the top? We don't take this top, we only take this top, because this main value store all the stack values. This main stack actually store all the stack values, and this means actually store the minimum value. Okay, so main dot top, and at the end we have get min. Let's suppose get minimum. Okay, so just put means dot top, nothing else. This is a, just evaluate it. Okay, let's checking it. Okay, it have something. Let's compare it. Okay, the push X operation has a typo. It should be why main? Why main? Because when we actually push a element, we have to check with this means, not the main. Yes, this is the mistake. Means of syntactic mistake. Syntactic mistake. So actually when we push this 6, we are checking with this 5, not this 5. Okay, so we push this 5 here, and now I think we can re-evaluate it. Okay, main dot, I make a lot of mistake. I make a lot of mistake. Main dot pu, push pop pop top top, spelling mistakes. Should, yes, it is working. Now let's go to the lead code. It is very simple question. Okay, what we are using, we are actually taking two stack. So take a stack of integer type. One is main, another one is means. Main to store the main value, main the main values, and means to store the minimum elements. Okay, so this is a constructor. Although we don't need to write any constructor here, it is given because we are using an object oriented loop. Okay, so don't need to write any code here. Actually, we have to push it here. Okay, don't write any code here. Come to push. What we push in the value first. Let's just take it here. Oh, it's working. I am very new to TL draw, and I yes, this is the one. This should be here. Stand. Maintain gap. Okay, ready. This is our algorithm. Simple pseudocode. Yes, this is our simple pseudocode. Okay, so push. When we push, we simply push it in both way. So when we push, we have to push first to the main array. So main dot push the value, and when we are pushing the value to the main element, we have to check that if the stack is empty, both of the stack. So when this stack is empty, like at the very starting the stack is empty, we just put the 5 here, and simply we put the stack is empty. There is only one condition: when the ins is empty, simply means dot push the value. Okay, the value. Else every time first let me check it. Every time first check and push. So means dot push the value. Okay, so we have to calculate. So minimum of the value or the top of the means. So means dot top. It's not mean, it means dot top. Simply this condition. So first we check that if any value present or not. When we push 6 here, we check this 6 is smaller than this 5. No, so just put the smallest one. Simple. Okay, so this is our simple push. So when we pop an element, so simply pop from both of them. So main dot pop and means dot pop. Okay, so we just pop element. So when you want the top of the stack is the main one. So top from the main. Okay, so it is simply main dot top. And when you need the minimum one, just simply say means dot top. It will always return the minimum element, and we are using inbuilt stack function, so it will maintain a whole new stack. So run it and check it. Okay. Oh, what is the mistake? We just forgot to return because it is an integer type. These two are void type. These two are integer type. So we have to return these two. Okay, so just run it, and yes, it's working. So everything, you must implement the solution with O of one time complexity for each function. So each function actually take big O of one time complexity, nothing else. So because this push and pop operation or the top operation from the stack actually take big O of one time. So the whole solution take big O of one time. Also the space complexity is big of n. We are using two stack. It is nothing but actually big O of n. So we can simply say approximately big O of n. Okay. So actually it will become big O of 2n, but we can easily ignore this integer and it will simply become big O of n. It is our space complexity, and we can easily say our time complexity for every operation will become big O of 1, because stack in will take big O of 1 time. So this is our given time. Okay, also if we reveal solution, this is the actual solution mentioning here. It is as simple as that. Simple. Just push and pop element. We need two stack, nothing else. Simple. Twin stack only. So this is the question, minimum stack, easy question, simple code, short video. Thank you. Check out this visualizer, use this link, and thank you. Thank you very much.